Welcome to another CO2 Monday. I'm your host, Trevor Matthews, and I'm super excited about this event. We actually have M&M Carnot live from the IIAR show 2023 event. He's on the expo floor right now with customers. It's a huge natural refrigeration event, industrial one. I'm super excited about this conversation because I'm speaking with the director of engineer, Frédérick, uh, Trubiano, and we're going to be getting into some of the equipment that they build, CO2 equipment, because I've been hearing about M&M recently for a little while, but Carnot I've been hearing about for years and years, and I know he'll tell a little bit about the story on the growth of CO2 with inside the organization, and he has a few other team members that's going to be jumping in under controls because he's going to take us around one of their piece of equipment that they have there, that they have installations in the field. I'm super excited about this. Frédérick, welcome to CO2 Mondays. How you doing?
Very good. Thank you very much for the invite. And then it's always exciting to be part of my first podcast live.
This is awesome. I'm super excited. Why don't you do an introduction to everyone? Talk about how you got into CO2 and what you're doing right now in your role.
Yeah, basically, if I go back, well, not way back, because I started in 2015 working in refrigeration. Basically, I got hired by LMP, started there learning. My first refrigeration system design was CO2. So I started working with CO2 from the get-go. And after maybe a year and a half, I started doing presentation about CO2, how CO2 works, what's different from synthetic refrigerant. And it was always funny at those conventions because I was speaking with maybe a year and a half of experience in refrigeration to people that have like 30 or 40 years of experience with different kind of refrigeration. So it was a great exchange of knowledge between me and them. And then a year and a half ago, got an opportunity to come and work with M&M Carnot. So I've been there, director of engineering. So we look at all the design, make sure we have the right design for the customer requirements, and then make sure we respect all the regulation, because that's always a main thing with that's happening with CO2, since we talked a little bit about higher pressure with CO2. A lot of inspectors are not used to this. A lot of installers are not used to this. So training is a big thing, and making sure we have all the right information and point the inspector that sometimes they don't even know where to look at. You point them directly at the code, say, oh, okay, here's what we have to respect. Here's how we do it. How we make it safe. And then there's been a big knowledge sharing the whole experience. It's been great.
Yeah, and that's what's amazing about CO2. It continues to evolve, and you've been in it for a long time now. But as you can see, it's still, even 7-8 years later, it's still evolving. We still got a lot to learn together collectively. How is that role as now becoming a director of engineering? So what are some of the things that you like about this in the CO2 and natural refrigerant world?
Well, with natural refrigerant, especially CO2, I feel there's always a new product coming out. It's always like figuring out, okay, with all the manufacturer that wants to go into it, okay, which technology would be a good fit with our technology, how we can make sure it's reliable. And because at the end of the day, the customer is what's important. What's matters to him is making sure his product is cold or frozen, and make sure we keep the whole system reliable. So basically, my main task, I would say, with M&M Carnot has been to make sure or increase the reliability of our system, make sure everything is top notch for industrial. And the main focus with the partnership with, well, not partnership, but like, as a one company with M&M, we're focusing mostly on the industrial system. So making sure everything is higher standard for all the piping. We're going to go over the unit that we have here that we're showing off at the expo, basically our new condensing unit with CO2. So, and then basically the other thing that another task that I have is basically passing along the knowledge to the team that we have to make sure basically all the individual that we have in our team are all professional with CO2 refrigeration. So they can basically, people can rely on them, and then they don't need any backup, so they can know the knowledge. And then with that knowledge, basically it helps them understand what the whole decision making of our system, why we have this component in this location, and how we can improve it. And it's always making sure by improving it or simplifying the system. So when you know how the system operates, when you know what every component does, you know, okay, oh, maybe you can remove one part or change this one to something else that's available now in the market. So it's always a learning process. And that's what's great about those shows too, that you can see different manufacturer and get the information almost before they're out on the market. Because a lot of the companies are showing equipment that are not, they're still in development or prototyping. So you can see, oh, okay, how you can integrate this for a system. It's always a great thing.
Yeah, that's amazing. So is this your first time at the IIAR Expo?
Yes, first time. Funny thing is they give a little banner when you come here. So I've got like speakers because we're doing a technical paper for CO2 heat pumps. I've got internationals and from Canada, first timer, exhibitor. So I've got like all the banners you can have.
Yeah, that's super cool. So how is the event? Like, so for people who have never been before, what is it like while you're there?
It's very focused on refrigeration and industrial refrigeration. So whatever you look at, it's because I've been to the ASHRAE Expo, both on the IIAR, which is more focused on commercial applications. So here, like seeing it, for example, like valves, like for CO2, you see the much larger valve, larger compressor, like we have right behind me, like it's a little, like an ammonia package that we build in their factory. So we go around, all the manufacturers have their largest equipment to show up, say, okay, here's where we are today. And sometimes they have like prototypes too of where they're going to be in a couple of days. So it's a lot of fun, a lot of knowledge. And it's fun when you're in that environment, everybody speaks the same language. So we talk about refrigerant, compressors, valves, everything. Everybody knows what you're talking about. It's very interesting.
And that's what's great about this event. Now, I've talked about this on many shows before. You got to get to these events. You got to network. You got to build those relationships. Talk to the manufacturers. Talk to the salespeople. Talk to the project managers, because this is how you get better and this is how you grow. Why don't you talk a little bit about? You've been at M&M Carnot for about 1.5 years now. So what about Can you talk about the development, where they were with CO2, how you're starting to grow with it and continue to grow with it, and then we can talk about the different systems that you have.
Yeah, well, the main thing with M&M Carnot, when we started, well, it was called Carnot Refrigeration back in the days, and we were one of the first to put CO2 system in the market. So our main concern was we wanted to make sure we had the safest system you can have, because you never know, the people who were operating those systems didn't have the knowledge of what CO2 is and how the main risk that we were thinking about is like, what if they trap CO2 liquid between two valves and then that create an explosion, and that makes a bad rep for the company, bad rep for CO2. So designing our system from the first time was like, okay, how make sure whoever works on it, like you can put a kid in there and there would no accident that would happen. That was our main focus at first. Now people are getting a lot more knowledge and technology is a lot more advanced and people know about CO2. There's been a lot of training a little bit everywhere. And that's what we've been doing too, making sure the contractor we hire and we work with knows about CO2, knows all the safety procedures. And we have like procedures for every operation, make sure, okay, here's how you do it. Here's how you make it safe, making sure your system is clean. And that's been a very big development, I would say, it helps us a lot move forward. So we talk about the system themselves. At first was, okay, we had to like design our equipment based on what was available, especially in North America, because like North America, CO2 was very popular. So we had to go to Europe, find a lot of the components and get them certified for North America. So there was a lot of back and forth, manufacturers saying, okay, here's what we can use, and then, well, regulation doesn't allow it. But now I feel like as the years pass, CO2 has become more and more popular. A lot more components are arriving here, already certified, ready to use. So it's much easier to get parts, and even some distributor has the parts on shelf now. So that helps a lot. But Carnot's been focused a lot on service too. So we have our 24-hour service team in Trois-Rivières that can support every system that we have. Because there's always some particularities from the control side, and we want to make sure basically the contractor, if he has a question, he has a point they can reach out, so we can help them directly on the site. And basically, I would say 99% of our site, you can connect to them online. Awesome. So our service technician can see the system operating, know how it's operating, what condition, okay, what's happening. Oh, customer said, oh, he's having a problem with his temperature. Because, oh, okay, here's what's happening. Can change some parameters remotely. Systems operating back online, fine. You know, it's all about support and making sure we train the people that are using them properly, so they can, next time they might not have to call us, make sure but if they need some information, some help, we're always there. We have a team dedicated for this all the time.
That's awesome. And that's one of the biggest things I think in industry, where in refrigeration, when you have that support, that's when the contractors feel confident. That's when they're going to come back. That's when they're going to recommend it to other end users. And once again, I talk about this so many times, about building that confidence. And by having support from a manufacturer, I think that is so important in today's industry, especially CO2, because there is so much more uniquenesses to CO2 over, say, supermarket refrigeration, or over even industrial ammonia plants compared to CO2. So you got to know those little tips and tricks. Why don't we talk about some
control.
Yeah, the controls for sure. Why don't you talk about the different systems? Because I don't know. I know you're in industrial, but what are some of the different systems that you have? Because I know Carnot builds some for commercial application, or used to, and now they build some for industrial. Why don't you talk about some of the different systems that you guys offer to market?
Yeah, basically it started with the supermarkets, lower pressure system that we still do. It's still one of our products that we produce for some customer that we've been doing for many years. So a little bit lower cost, lower, because the pressure of the equipment that are installed on site are lower pressure. So we have different design for it, different technologies. Then we have our chillers, which are higher pressure system to cool down, to be cooling down glycol or just water or brine for ice rinks, for example, could be for different applications. Whatever the customer needs, we can do it for cooling a different process. We have the industrial racks that are basically much larger, could be indoor or outdoor. We do the panel ourselves in-house, so all the design, and that system can be just like dropped in beside the site if it's outdoor. And then that's normally those larger system has larger compressor. We can do like multiple suction temperature at the same time on the same rack, all with the right protection from suction accumulators, making sure we have proper, if there's any liquid coming back, we protect our compressor, make sure everything works well. Then we have another type of unit that we came out not long ago, which are the Aquilon DS, which are the distributed system. These are CO2 condensing unit for industrial application, which I have right here. Maybe I can just share flip my screen.
Yeah.
You can see a little bit what we're talking about. So
okay, awesome. Yeah,
whole screen of the unit. So you have the reservoir. Here we have the compressor section.
oh nice.
So all
Lots
the piping
space.
is done, all stainless steel, making sure servicing is easy, making sure you have access to all the components. And then we have our own adiabatic gas cooler system that we are basically seamless integration with the compressor rack. So then you have like the water control all integrated in the unit directly.
And so would you see this more on process plants or some larger plants where you'd place them on a certain walk-in box and it'll just do one big box? Is that correct, or multiple?
There's different application for those. I would say one of them would be like for a small warehouse or like coolers that they would put those, because we can do those with low temperature or medium temperature only. Like this one is a medium temperature, low temperature. So we have like low temperature accumulator, medium temperature accumulator. Yep. And we've seen just warehouse, or sometimes where you have a larger system, you might have one large system and one of those that will produce like cooling for one small room that's all the way at the end of the warehouse. Instead of running piping from your main system all the way to the end, you just put that unit back there for, let's say, for the dock, for example.
Yeah.
And then we can add heat reclaim to that unit. There's a lot of options we can do on this type of system, which are very useful for the customer. For example, like we do hot gas defrost, so you don't have as much electrical load when you're operating a system.
Okay, so good question on that. So do you do options on hot gas defrost? Do you use if it's a low temp, medium temp, do you use the low temp discharge pressure? Do you use the medium temp discharge? What's your design on that? Or can you talk about that?
Yeah, we have multiple design. For supermarket, we've used a lot of time the low temp discharge. Yep. And what's specific to M&M Carnot or industrial design, we use what we call the intercooler.
Okay.
So basically we're cooling down liquid even lower than you would normally have straight in your receiver to increase the efficiency of the low temperature compressors. So
Okay, so you have a whole separate vessel because in
yeah,
in a supermarket application, most people when we talk about it, you go from your gas cooler through your high pressure valve into that flash tank receiver, and then
yep,
from there it will go from your liquid line to an interstage cooler. Or how does that kind of work? If
yep,
you can give us a that's how it works.
exactly. So basically, you have from your flash tank. Basically, you have your liquid going out for your medium temp compressors, because medium temp could be running
Yeah,
around like say 20 degrees Fahrenheit. Sending for a supermarket, you would be sending out liquid around 35
yeah,
degree Fahrenheit, because your in the supermarket is going to be a lower pressure design. And then you have an interstage. So basically, you send liquid to that interstate receiver. Then so we're dropping the liquid temperature and pressure to about that same pressure as the medium temp are operating. And then we take
nice.
that liquid from there, sending to the evaporator. So you have less mass flow that the low temp compressor
Yeah,
needs to process. So you're increasing your efficiency. So by reducing the mass flow required by the low temp, you're reducing the mass flow required for the medium temp at the same time.
yeah.
And it helps like reduce the size of all the compressors, increase the efficiency. That's the big thing that we've been working hard, like to make sure we have like something different that makes a lot of sense, and a lot of people are very interested with it.
Yeah.
So
So
we
and
use
so
this technology for supermarket and industrial to be
no, and
able
I
to do
really like
it.
that. So just so everyone knows who's listening on the podcast. So you have your flash tank receiver at say 35 Fahrenheit. You actually go to another one that's 20 degrees Fahrenheit because it's colder. We think about subcooling. That's what I think about all the time. You got colder liquid. So when you have colder liquid, that makes a big efficiency gain in your system.
Yep. Yeah, it helps everything. So that's for supermarket. And then if we talk about like more the industrial application, most of the time for let's say hot gas defrost, normally we would use the high pressure discharge from the high pressure compressors to defrost the coil. That allows for much faster defrost, helps like reduce the time you're going to be spending in defrost, and then make sure all your coil is super clean before you restart cooling. So there's different tricks with the control that we can do that we've been working on like internally and with the different control manufacturer, and that's always been a challenge, like making sure the control follows or required specification for our system. And that's why basically we basically developed a lot of the control program ourselves in-house. And then with M&M Carnot being all together one company, now we have like two control companies all together. So we have M&M System that's right behind us that we're gonna be joining us a little bit later on. And then we have Logix on the other side that does control too, that we can basically all work together, make sure everything is up to our specification, the system is going to be operating properly.
Yeah, and that's awesome, and it's so important. This is the key about CO2. This is key about the industry. It's not even CO2. We're getting into controls, and I've been seeing it for 6, 7, 8 years now. But controls is going to be the number one thing in all refrigeration application. It doesn't even matter if it's your fridge in your house. There's a ton of controls on there. You just don't know it when you're just pressing the buttons, turning it up and down. But controls is one of the things that we all need to get better at and learn a bit more, because that's going to make you more efficient and effective working on anybody's pieces of equipment. And when you learn those, it takes time. It doesn't happen overnight because there's so many different controls out there for CO2 systems. And you just heard Frédérick talk about a couple there. They got their own controls. They got Logix, and maybe they even, I don't even know if you use other ones as well, but you got to know how to at least navigate them and understand the processes with them. And then over time, start to learn them more and more. You don't learn this overnight. This takes years and years to learn controls. Just don't get frustrated. Just learn them and continue to grow your knowledge. I love that. Awesome. So you said you did say one called Logix. Do you guys own that company, or is that a third
Yes.
party? Oh, you do. You want to talk a
Yeah.
little bit about that?
Yeah. Well, basically, Logic could go on their booth. They're right behind me. I don't know if and see if they're ready to
Oh, that's
join
okay.
us.
No, we can keep going with the unit. That's fine. We can talk about the unit a bit
Let's
more.
see. He's right there. Let's see if he's going to be ready. Okay, he's putting his mic on. Let's see. So here's a Logix booth.
Oh, well,
So
that's a pretty nice screen. So what I really like about the new controls that are continue to come out, there's more and more pressure transducers, temperature probes, layouts for the control system, so you can see the differences in all sides of the system. And that makes a big difference when I can see what's going on the high side, transcritical side, what's going on the low side, all at the same time. And that makes troubleshooting so much more easier, I believe, in CO2 systems.
Yeah, it does. So we have right here, basically, everything is integrated. So you have all the power for the
So you got a
unit.
screen right on the front there. Is that a control screen? Or is
That's actually a new control. Basically, we were integrating Logix control with their Aquilon DS unit.
Awesome.
So the Logix is going to be directly from factory inside it, and we have all the team to support the control. So it's basically now part of their one company.
Yep.
So everything is right there, and you have remote access. There's different options we can have, and we can have this controller integrated with the rest of the building or with the multiple units all together. So with one place, you can see all of your units, everything live, and with all those data, all those systems that are running are all registering the data, the operating data of the different systems. So you can know, okay, is my system more efficient today, or was it more efficient last year on the same date? And you can know, okay, oh, here's what's happening when we operate at higher temperature, lower temperature, and we can do fine tuning of all the adjustment live as the system is operating throughout the years.
Awesome. And I think that's something key that more and more technicians are going to need to learn and understand, because after you install a CO2, and really any system, it doesn't have anything to do with CO2, it could be even industrial. After you install it, you run it for a few months, there's fine tuning that needs to be done. Yeah. And this is not happening a lot on standard refrigeration system as well as CO2 systems. And I was at a site last week and I just watched the manufacturer go in and the contractor installed and did all the setup. And I go in and he's like, Trevor, I want to show you a few things. It goes into the control. You see all these electronic valves. They are just all the default program. So nothing's been changed to really fine tune it. So that valve is working perfectly on temperature or superheat. And he's like, Trevor, you need to understand that this valve here affects other parts of the system. So if this one's not running right, it could affect the fans, it could affect the high pressure valve, the flash gas bypass valve. And it's something that now we're in systems that is full communication, which makes sense. And if you want the highest efficiency system, you need to make sure they're all fine tuned. Do you come across that stuff?
Yeah, it's making sure all your system all communicate together. So if there's one error somewhere, and then your system can adjust to it, or you can have, basically that's one thing we do on most of our system, making sure if there's one valve that has a problem or whatever, a sensor that has a defect, we can isolate that system to make sure we can continue operating. Because let's say for an industrial system, it's even more critical. Sometimes you have like 60 evaporator, and you don't want to shut down your whole system because you have one of the 60 evaporator failing, So you can control it, isolate it, okay, continue operating with the other ones, and then you send, basically the system can even send emails to the service contractor.
Yeah.
So the contractor knows, okay, well, you have the problem with this evaporator, and then sometimes you can even send like procedures of like, here's what you have to go look at, and we have our technical support to support them, the contractor, to make sure whenever they get there, they know what to do, they know what to look at. I think Mike finally got a setup. Let's see.
Mike, what's up, bud?
Hey, how you doing?
Oh man, perfect. I can hear you perfect. Good. Thank you for taking the time to do this.
Yeah, I got to invest in this headset. It's a lot better than the one I have.
Mike, why don't you do an introduction for the group on what your role is at M&M and what you do?
Okay, so I'm actually with Logix, which we're a division of M&M.
Okay, Logitech. Okay.
I've been with the company over 6 years. My focus is selling industrial refrigeration control platforms. I've probably been doing this for 15 years, and I've been in the refrigeration industry well over 30. So I've been on the supermarket commercial side and worked my way up and have touched both manufacturing, sales, and a little bit of contracting as well. So I got pretty good overall experience and understanding of the industry.
Awesome. Well, so is Logitech only in industrial? Is it in commercial? What areas does it play in?
So our focus is industrial. The platform was developed 30 years ago by two gentlemen, the founders of the company. We developed an industrial control, so our hardware is hardened for industrial applications. So what's the difference between industrial and commercial is really where's the hardware going into, is the first part of it. So industrial typically goes with a 4 to 20 milliamp signal, which is a robust type signal. Sensors are better quality, they don't drift and so on. And then on the software side is really where we shine. It's our understanding of how to control an industrial refrigeration plant, whether it's ammonia or CO2. So we bring that knowledge to the game and provide a solid control platform. As most people are aware, the industrial side, there's no two systems that are identical. There's always something a little different. Customization is the standard for us. So our software is developed to meet the custom application for the customer.
Okay, so with that software, do you have controllers like Logitech controllers that will communicate with all the different valves and all the different components, or like is there third-party integration? How does it really work, or do you build the valves and stuff like that, or are you just a controls manufacturer?
We're just a control manufacturer, so we're controlling compressors, condensers, motors, VFDs, motorized valves. We're looking at ammonia safety sensors. We take a holistic approach, and we prefer to do that on any project. Sometimes some customers may not want certain control of one aspect of their system, but really they're not taking full advantage of the control strategies if they do that. So we can talk to third-party devices. So on compressors, I can talk to an M&M compressor, I can talk to a Frick, or I can talk to a Vilter compressor and integrate them into the control system for performance, safety, and energy efficiency.
Awesome. So you guys started, you're in industrial, now you're doing CO2. What was the transition? Because there's a lot more components to control. You have to build PIDs and algorithms for the CO2 side for, transcritical, subcritical. How was that designed? Were you involved in any of that with the team and the process of that?
It was an interesting development. We learned quite a bit. We had some outside support that helped guide us along. We've got two projects in the works. One has been completed and started up and actually working quite well. And we've developed some very interesting control strategies for the CO2 side. So CO2 being a strange fluid when it gets to a certain temperature and pressure, being somewhat liquid, somewhat gas, somewhat weird, as it's in the transcritical. I like to explain it that way. Learning how to control between transcritical and subcritical in a refrigeration system and keeping things operating smooth is really the key. And I think that's where we're going to be shining the most into how we control that transition.
Yeah, and I think that's so important. It's all about that control. When you have the proper control strategies in place, systems work very smoothly. Very smoothly in CO2. Do you have any images you can show me? Do you got a controller there to try to show everyone what's on it, what's involved with it?
Yeah, so this is our standard graphics and our standard platform. It's very user friendly. I'm going to switch sides with you. So point and click, it'll bring you to the devices. You can bounce around from screen to screen. And then, for example, you can click on a vessel and it'll bring you to your, I don't have the code to get in here, but it'll bring you into the set point screens.
Yeah.
Very user friendly. It's got capability for remote access. It's got a remote alarming, so notifications when something's going wrong. It's waiting for responses on that as well, so alarms could get acknowledged, which is critical. Especially in refrigeration, especially when temperatures have gone out of whack. Data logging capabilities, user adjustability, so the user can go in and make adjustments and changes to how they want the system to operate. They can kind of fine tune it to their specific application. So all that's built into here, along with the hardware being industrially hardened for the applications.
So for me, it looks like a nice clean screen. So would a contractor be able to design this, or is this something like, is it a kind of like I could go in as a controls technician, add all the different products there, or is this something that you guys have to do for them?
On this particular product for the Aquilon, this will be a standard product.
Okay.
And it'll be configured for the package, for the number of compressors and for the number of evaporators that need to be controlled. So for us, it'd be a standard package, slightly field configurable for temperatures and set points and so on. They leave that up to the user, but designed specifically for this, for the Aquilon. So the Aquilon could be considered like an engine room, like you'd see on an ammonia side of a central station. We've taken that same approach, but what we wanted to do was kind of modularize it so that the customer can have his flexibility to be able to change what he needs. But they wouldn't be able to go in and make changes to the graphics or add or delete things. This is all done at the factory.
Awesome. So what are maybe one or two tips on this controller if a technician was going to go work on one of these equipment? What are one or two maybe navigation tips or something they would really want to know if they're going to work on this piece of equipment?
So really, you go down to you go up to the menu bar here. I got fat fingers, excuse me. I can't get my fingers to work. Here we go. So here's your set point screens. That will bring you to.
Oh,
if
great!
You want to change a defrost schedule on an evaporator is a good example. So if I can get to. Whoops. There we go. Air unit set points. It brings me to here's what's currently being controlled. And then if we can get back to that screen. Sorry about this. We've got to protect the screen on here, and my fingers are not the most agile.
The cameraman's doing a great job, so it's perfect.
Yes, he's doing a wonderful job. So in this particular case, actually, I'm locked out because of security, but you can go drive down through the menus.
Yep.
And get to setting set points. So if you want to change your suction set point on your compressors, on your stagers, you can drive it through the menu there.
Yep.
You can actually go to pop on the stager screen here for whatever temperature, and you can click on whatever menu you need. Go in and, for example, let's see if it even gets us here. Yeah, it's asking for password, and here you go. So it's got the set point screen right here. You'd be able to go in and change what you where you want your system to be operating in. We've got data logging capability, but we don't have data built into this demo, so I can't really show you that.
And how long will that data log? Can I, like 2 years down the road, can I go back and see what it was on, March 13th?
You could probably go back 10, 15 years. It saves the data at 15-minute intervals. And then we've got also what we call a quick trend where it actually recycles the data. You can save it for like every 6 seconds. So the granularity allows you to actually see if a valve opened or closed when you're trying to troubleshoot. So ideal for a service person to go in and say, the valve did open and it did close, why, or it didn't.
Yeah, exactly. And I think that's super important for any service technician to understand that you may need to have that shorter duration to see what is happening quicker. So that's great.
Exactly. And then, a sensor fails, you'll get an alarm notification and so on. So 3 o'clock in the morning, when you get that service call that you dread, you get a notice on your phone or you get an email. It'll send you the alarm. You go back in, you get into the system remotely, acknowledge that alarm, and sometimes you can troubleshoot the issue right from where you're at, or if you got to go in and actually change a failed component.
That's awesome. That is awesome. Well, thank you so much for giving us a quick demo on that. I know there's a lot more to it. Where can people find out more about Logix if they want to learn more about this controller and what you guys do?
Just look us up on the internet, Logix Control, Logix. Controls, controls with an S.
Okay.
And if on the website, we've got a brand new website, looks great. There's ability to pull down information, and then also just send us an email through the website, and we'll provide information to contact the individual if there's more detail they would like to learn about us.
Awesome, Mike. Thank you for that. And it's
You're
Logix.
welcome.
I was calling it wrong. You want to throw
That's okay.
Frédérick back on there, brother?
Yep. Very good. Nice talking to you, Trevor.
Thank you so much.
Switch it back. There we go.
Frédérick, you crushed it. You're
Yes.
cameraman. You're another profession, and
Yeah.
you're another profession. So thanks for showing
Yeah.
us that. I think that's pretty cool, having it integrated right into the unit. Somebody can see all of it. I didn't ask Mike, can you put that outdoors? That screen, could that be outdoors, or
Yeah.
is that?
Yeah,
Oh,
that's why we put like a protective film to make sure it doesn't get impacted by UV rays. There's a lot of protection you can do, and it's something we've done in the past too.
that is awesome.
Yeah.
Frédérick, I really appreciate you taking the time to do this. Is there anything else that you'd like to share with the audience? Some of the stuff that you're doing, some of the stuff that you're coming out with down the road?
Well, actually, another thing we want to talk now, it's like on the other side of our booth, we have like an M&M system. Basically, we have Hank right here. He's trying to join in. I'm not sure if he's going to be able to, but let's see if it works.
Trevor, thanks so much for having us. And I wanted to cover this diversity between, so here you've got Frédérick, the young brains, young guys, and then you hit me and Micak from over in Logix. You notice my hair's still here, but it's an awful lot grayer.
It's beautiful.
So, yeah, I've been doing industrial controls and refrigeration now for over 30 years, and M&M Refrigeration, M&M Systems, and now as part of the total group M&M Carnot. And it's been real exciting for me as one of the old guys to be involved with the young brains and the young talent out of Lavallée-Trubiano with helping and learning all the transcritical stuff. I mean, in CO2, we cut our teeth on the ammonia CO2 cascade systems with our first one going in about 2003. So, and CO2 even then was a different animal for us, from the ammonia side or pure ammonia side. We still do a lot of that as well, but the transcritical stuff has been really neat to get involved with. A lot higher pressures, a lot smaller.
I lost you. Yeah. No, I got you still in your back.
Okay. Yeah. So it's just been a lot of fun.
Yeah, well, it's a huge, I'm sure it's a huge learning curve for you. What I love about it, you're still interested in it. You've been doing it for 30 years and you still want to learn. And that's what's great about refrigeration.
And what's great about it, again, from my standpoint, is that being involved with the young brains and on the new technology and stuff like that, and being able to bring our expertise from the control side into the transcritical world has been key. Because a lot of our customers, from the industrial side, the refrigerated warehouses and stuff like that, they're looking for to move to CO2, but they're familiar with the types of controls and things that we've been giving them over the years, and so that's what they're expecting. So that's what we've done here. This is our Aquilon industrial panel, and it will sit on the end of one of our units. Can be on the roof, or can be in an engine room, as Frédérick said.
Awesome.
The difference between the DS that's here in the booth and the Aquilon Industrial is the DS is smaller, has an integrated gas cooler. The Aquilon Industrial is pretty much an engine room in a box. Can be 4 compressors, can be 20 compressors. So they get to be quite large. But still, even in some of our customers, there might be multiple Aquilon industrial skids to control the entire system. So
wow.
It's but yeah, so let me just open it up here real quick.
Yeah, let's check it out.
So this is our standard microprocessor setup that we've done.
Nice.
And this is our version 4 micro. IO racks go up for different things. lots of compressor IO. All the analog signals come in the bottom for pressures and temperatures. With the CO2 transcritical, it's a lot more instrumented than a normal ammonia or even the cascade systems would be instrumented. Valves are smaller, but move a lot slower because of the pressure differential. Stepper motors for superheat control on the evaporators and for the high pressure valves and flash gas valves. So componentry is a little bit different, but pretty much the same, and we're able to do it with our standard micro. So in here, software-wise, as Mike Micak pointed out, this is what makes us who we are. I mean, the hardware is important and everything like that, but it's all the knowledge and all the capabilities and all the algorithms and everything that are in here. And that's, again, what's been really cool with regards to it, is we've had this pairing of the two where we've, the guys in Lavallée-Trubiano had taught us about the transcritical side, and we've been soaking up as much as we can, and we're pushing a lot of our control methodologies and processes into the transcritical world, and also our development process with our quality control and our testing and so on and so forth. In fact, this is a copy of a prototype that we have running up in Lavallée-Trubiano.
Awesome.
So this is the physical controls, and then if we go over to the display, this is the PC software that we have that can either be mounted on the panel or run remotely on a desktop.
Okay.
You mentioned you talked about the displays and everything, but even notice down to the valve numbers that transfer into things, hand valves that we're not controlling, because the graphics, when you've got them to such detail, become a learning and a training tool for your operators, because they don't have to learn things twice. And that's one of the key things that we try to do, is we try to present one way of doing things so that operators can learn the system without without having to continually go back to a drawing or whatever to learn it. But then still provide them with information. Some things, you get more information as you zoom in on things. Additional data comes out with different levels of details. We've got tooltips that'll pop up, which tells you additional information. Then from here, I can drop down onto displays, more table-based displays for the micro, and go out and change set points and adjust things and so on and so forth.
Yeah.
What I love, this is and Mike was talking about this a little bit as well. This is a demo, and this is actually live data that we captured live off the prototype when we were running it, and we're playing it back. So you can see compressions running, pistons moving, levels go up and down in vessels. We want the operator to be able to, the key is we don't want them to have to think when they look at stuff. They shouldn't have to look and read and do anything cognitively to notice that a compressor is running. It should be obvious. Valves, let me see if I can find a valve that's partially open here. This one's just a little bit open on the hot gas valve. You can see it's just a little bit white at the bottom. It'll gradually go over. Let's go out to one of the air units here. So then from here you can zoom in, tap, get out to a. I'm having the same issue Mike was having my whole thing.
What I love, though, the biggest thing there is like what you said earlier. You got the whole piping schematic on there. Yeah. And that's the biggest thing. I do so many CO2 trainings, and I think the number one thing is getting the guys to understand the piping schematic and walk in step by step through it, so you know exactly what valve you're at, or whatever transducer or temperature probe you're at. You know exactly where it is in the system, so you can match that up to the controller. So I think that is awesome that you guys have that.
Yeah, and the key is that you want to be providing constant feedback to the operator on how the system is set up, how it's piped, and where the valves are, and so forth. So, like here, you can see the EEV, electronic expansion valve, growing and opening. Even on the big motorized valves, we've got to position because on some of these valves, when we tell them to open, they move so slowly because of the pressure differentials and the actuators on them that it might take a minute or two for the hot gas valve to physically open. So even there, we're growing the valve to show you what percentage open it is. So
that's fantastic.
To provide that sort of feedback to them, at a glance, so they can do it. And it's the same thing with alarming. I don't have that set up in the demo. I don't think. I don't have, when I captured the data, I didn't have any active. But when an operator shows up and looks at the screen, you shouldn't have to think about what's wrong. You should come up and say, hey, if the compressor failed, it should tell you exactly why. If an evaporator is shut down, it should tell you exactly why. We tried to cut down on things, but then again, you also have to be kind of careful how you do things and how you set things up, because you don't want to give the operator cognitive overload when they're looking at stuff. And you make it too hard for them to pull out data. So you have to keep things organized. Here in this part of the planet, there's these from left to right, up and down. So this all gets into how you create the displays and how you do it. But again, constant feedback all the time. Pipe colors, yellow is hot gas in this case. Orange is defrost return. Brown is oil. Red is liquid, and different colors for different temperatures. Medium temperature is light blue. Dark the royal blue is the low temperature. Subcooled liquid is purple. Glycol, I got glycol up here in the floor heat screen.
Yeah.
So you constantly are providing information out to the operator when he's not really asking for it. It's just obvious. It should be obvious, and it becomes familiar. So
that's awesome.
It's neat. We love the zoom and pan. This enterprise product has been the coolest toy on the block for a while, and now with the capabilities and touch screens, we're able to bring it out and put it on a panel, but you can still have it on the desktop too. And now it's a client server application, so I can be doing something here on this screen. Somebody can be on the desktop doing something completely different, and it just kind of flows. So it's great. But alarm notification out to the world through email, text messages, and then from here, we're taking the data, because this is the next big step, and we're taking the data and pushing it out to the cloud, and then through our Pulse product, you then can collect a bunch of information from different facilities.
Awesome.
And put it all on one screen.
Yeah.
So,
that's what customers are looking for, because if I got 6 or 7 facilities, I want to know where everyone's at. What's the efficiency of this facility versus that facility in this climate zone, and to make adjustments, right? And so when they get another facility, is like, how do I make the better, more efficient facility the next time? All on data.
And now with all that data headed out to the cloud and being stored, now the challenge is how to take advantage of it to do maintenance, to do energy savings, to do integrations with warehouse management systems, and
that's awesome.
For all kinds of things. So it's we've got the data flowing, and we're working on the AI portions of it as well. So
I love that.
It's a fun time. It's a fun time.
It is
to be an old guy in the refrigeration business.
Yeah, it's a fun time to be a young guy too in it. I love this. Hank, I want to thank you. I want to thank you for taking the time to walk through that screen with us, talk about the product. How can people get a hold of, M&M Carnot, get a hold of you, get a hold of the company if they want to learn more about this product or learn about more of your guys' business?
Well, certainly if you're at the show, stop by and play with it for real. I was just talking to a couple of guys that stopped by, and I love it when from my standpoint, when I see somebody that's fresh and new that has experience, all of a sudden start walking up and zooming and panning and doing things on the display, because that means that we've got it right and it works like what they expect it to. So but M&MCarnot.com, our webpage, that'll get you out to the controls side, and the M&M Systems webpage is still up, but we're transferring all that over to be as one company now. We're merging it all together, so it's great. And it's the other thing, just to throw some stuff in is that with Logix on board as part of M&M Carnot, now we've taken two groups that have been, at the forefront of industrial refrigeration control for 3 decades, and now we're merging them together, and that's been a lot of fun as well. Because we're learning a lot from each other, even though we've all been through a lot of shared experiences throughout.
I love it.
So it's been, it's a like I say, it's a neat time to be involved.
I love it. And it is because it's going to continue to grow. We're going to continue to learn. I love that you still have that passion for refrigeration, Hank. So thank you so much for taking the time.
Yeah, cool. Well, I appreciate you having me.
Are you still there, Frédérick?
I think so. Can you still hear me?
Yeah, perfectly. Perfectly. Well, I want to thank you, Frédérick, for taking the time to do this. I know it's a busy show. You got a lot of customers there. Give us a good idea of what's going on at M&M Carnot. Do you have any final thoughts? Anything you want to share with the audience before we go?
Yeah, I would just like I said, thank you very much for allowing us to share what we were presenting here today, not only to here at the show, but to everyone basically. And we're going to be able to use its content for other people so if they wanted to see what we had to show over here. And there's still a lot of progress happening in refrigeration, and refrigeration is very a small niche sector. So, and what's fun about it is I've been in it for about almost 8 years now, and everywhere we go, you always see the same people. So basically, refrigeration is basically like a big family. So don't hesitate if it's something that's interesting that you're interested in, controls, challenges, new technology. Don't hesitate and come join refrigeration in general. And if you're interested about joining us, we're always looking for new people that are motivated to learn about technology, control, pressure, and being part of that big change that's happening in refrigeration system. So don't hesitate to contact us. I think we had some links with their website. So yeah, it's been a pleasure.
I'll throw the links into the description so whoever's listening. I want to thank everyone for taking the time to come and hang out with us for an hour, listen to this. And if you're on the podcast and you enjoy the session, please share it with someone else. Share some of the CO2 knowledge with others, because it's really important to get that knowledge out there, because we're all in this together. CO2 is going to continue to grow, and how it's going to grow is from all of us sharing it. Frédérick, I want to thank you so much for taking the time there. And I want to thank everyone for hanging out at the CO2 Mondays. Have a good one.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.